to Operation Management class. In this video, we will learn further about the tools in Total Quality Management, continuing from the previous video. Let's see about these tools.
Let's continue our discussion on the Total Quality Management concept. In the previous video, we already learned about the 3 out of 7 concepts of Total Quality Management, which is continuous improvement, Six Sigma, and employee empowerment. In this video, we will continue on the last 4 concepts of the Total Quality Management, which is benchmarking, just-in-time, Taguchi concept, and knowledge of Total Quality Management tools. Let's begin with the benchmarking. Benchmarking involves selecting a demonstrated standard of product, services, costs, or practices that represent the very best performance for processes or activities that is very similar to our organization. The steps for developing benchmark are: first, determine what to benchmark. Second, form a benchmark team. Third, identify benchmarking partners. Fourth, collect and analyze benchmarking information. And lastly, number 5 is to take action to match or exceed the benchmark. When an organization is large enough to have many business units, it may be possible to do internal benchmarking. Typical performance measures used in benchmarking includes percentage of defects, cost per order, processing time per unit, service response time, customer satisfaction rate, etc. Now let's move on to just-in-time or JIT. Just-in-time has the philosophy of continuing improvement and enforced problem solving. JIT systems are designed to produce or deliver goods just as they are needed. Related with the quality, JIT cut the cost of quality by reducing scrap, rework, inventory investment, and damage costs. Furthermore, JIT improves quality by shrinking lead time and creating an early warning system for quality problems. With better quality means less inventory and better operability of the system. If consistent quality exists, JIT allows firms to reduce all the costs associated with the inventory. JIT employs full system of production scheduling, including supply management, where the production is held only when signaled. Most of the quality problems are resulted from the poor product and process design. Genichi Taguchi, a Japanese quality guru, provided 3 concepts aimed at improving both product and process. Product and process quality that consists of the quality robustness, quality loss function, and target-oriented quality. Quality robust products are products that can be produced uniformly and consistently in adverse manufacturing environment. Taguchi's idea is to remove the effect of adverse conditions instead of removing the cost, since this is cheaper to implement. In the Taguchi concept, there is a quality loss function that identifies all the costs connected with the poor quality and shows how these costs increase as the products moves away from being exactly what the customer wants, as can be seen in this figure. In this figure, we see as the product move away from the target, either this is going to the upper or to the lower specification, the loss to society as represented by this formula L is equal to square of D, which is the distance from the target value, multiplied by the C. With this general form of simple quadratic formula, all the losses to society due to poor performance are included in the loss function. Target-oriented quality, the third concept by the Taguchi, strive to keep the product at the desired specification, producing more and better unit near the target with the philosophy of continuous improvement. To implement TQM as a continuing effort, each member of organization must be able to use the technique and tools of TQM, that is known as 7 tools. These tools include check sheet, scatter diagram, cause and effect diagram, which is categorized as the tools for generating ideas, and there is a tools for organizing the data that consists of Pareto chart and flow chart, and lastly, tools for identifying the problem, which consists of histogram and statistical process control. Let's discuss this tool one by one. Check sheet is any kind of a form that is designed for recording a data. The recording is done so that the patterns are easily seen while the data are being taken as presented in this figure. In this figure, we can see there is 3 types of defect. Defect A, defect B, and defect C, which is recorded in each hour in which those defects occur. Scatter diagram show the relationship between two measurements. An example is positive relationship between length of a service call and the number of trips a repair person makes. Negative relationship between the absenteeism, as you may see in this figure, and productivity. And setelah. Cause and effect diagram or Ishikawa diagram or fishbone diagram is another tool for identifying the quality issues where each bone, as you see here, each bone represent a possible source of error. The operation manager starts with 4M, which is materials, machine, manpower, and method as the causes. Those 4M provide good checklists for initial analysis. Pareto chart is the next tools that we will discuss. Pareto chart are the method of organizing errors, problems, or defects to help focus on problem-solving efforts. In Pareto, we generally conclude that 70 to 80% of the problem, which is in here, in this category, lies in here, in this category, are the result of only 20% of the causes. Flowchart. The flowchart is a graphically present a process or system using annotated box like this one, a gateway like this one, and interconnected line as presented in this figure. This is simple but powerful tools to make sense of a process or explain a process. Histogram. Histogram shows the range of value of a measurement and the frequency with which its value occurs as presented in this figure. Histogram show the most frequently occurring reading as well as the variation in the measurement. Statistical Process Control or SPC monitor standard, make measurement, and takes corrective action as a product or service is being produced. Sample of process output are examined if they are within acceptable limits, which consist of lower control limit and upper control limit. Sample of process output are examined if they are within an acceptable limits. The process is permitted to continue. Otherwise, the process is stopped. If they found there is a process that is out of the limit, the process then stopped and the assignable cause is located and removed. The SPC uses control chart as a graphic representation of data over time that show upper and lower limit for the process we want to control as presented here. We will discuss about the detail of SPC in the next video. Make sure to stay with me and see you in the next video. Thank you.
Thank you so much for joining me in Learning Operation Management. See you again in the next video.